Hello, here's Andreas Blumauer from Semantic Web Company. So this is the second part of the tutorial for semantic knowledge graphs. I will show you first of all how to create and maintain such graphs and then how to use them within a search and analytics application. So I log into the pool party Desaro server. So that's a backend component in which a taxonomist or knowledge graph manager would maintain the knowledge graphs. It's not meant to be used by the end users, of course. So I will, as an example, now load the medical subject headings, which is a broadly used taxonomy in medical organizations. It's linked to DBpedia in that case, so it's a network of graphs actually, which you can use here in the background. And you see here on the left hand side a hierarchical view on all the things within mesh. So short statistics will show it's about 27,000 concepts with a lot of synonyms, like 200,000 terms are in this knowledge graph, and quite a lot of relations between the things, like 36,000 roundabout. So I can now look up maybe one of the things contained within mesh. You see here, for instance, heart, which belongs to the cardiovascular system. It has a couple of narrow concepts. It has different alternative labels and labels, preferred labels, a scope node. And now I can go maybe to one of the next concepts related to that, and so on. So I can already traverse the graph within this environment, but of course it's rather meant to be used for the maintenance purpose in that case. So here you see, for instance, the corresponding link to DBpedia. I could look up what's in there. So here are a couple of other facts around this certain thing. So this can now be used for an end user application. So let me show you an example within SharePoint. So here we have a couple of documents stored within this site collection, and also some wiki pages. In that case, it's about renewable energy, so a different domain. Therefore, we've been using a different knowledge graph called REGL, the renewable energy and energy efficiency thesaurus. And as a first outcome, you see here all the documents have been tagged with things from the knowledge graph. And that's done, of course, automatically in the background. As a quick win, now I could click on one of those things like climate change and get just a short list of all the documents which have some relations to this certain thing. So that's a quick win. And on top of that, you can use this facility for a much better search than the one usually being found in a standard installation of SharePoint. So as a first step, I can fetch here one of the projects or knowledge graphs I have installed on that server, and now can look something like carbon offset. I've heard maybe somewhere, or would like to know more about what my company has produced in this field. So I see a autocomplete here, which also is derived from the knowledge graph. Of course, all the synonyms will be used in the background to do a search. And very similar to the Google Knowledge Graph, I can now see here a list of documents, but not only, but also a fact box to my search term, which is carbon offset. So I have here an image, I have a description, synonyms, more general, more specific related things to my search term. And see very quickly in the document view what my potential search results are all about. So that's a very efficient way to fetch documents which are really interested in a certain context. On the left hand side here, I can further drill down and say, okay, I'm just interested in the context maybe of emissions. So I get a shorter result set now. Or I could also say, I'm interested in carbon credits, something related to my original search term. And I see here I get 2 documents only, and so on, and can drill down once again. So it's a search application based on a knowledge graph which was designed for this certain domain. It helps me to become more precise search results. It helps me, well, it's a kind of an assistant to formulate queries, especially if I'm, let's say, not 100% familiar with the domain yet. So this fact box here on the right hand side helps me to make a more specific query in contrast to a search engine which just provides a simple search form. All that is based on a very consistent knowledge model of my domain, which is in that case the renewable energy and energy efficiency domain. So the documents themselves, which build the index, are automatically tagged. So as an example, I'd like to show you how that can be produced, such tags. I can create a new wiki page, maybe in that case. I go and fetch some data from Wikipedia, get some stuff from there, and fetch the text from here as a small example. So I just produce this document here and copy paste the information and save the data. So this tagging of the document can either be produced in the background automatically, instantly, or in a certain time interval. It can be done with PDF, it can be done with PowerPoint, whatever you prefer. And in that case, here we go, here are the produced tags, and I could now, if I like, reconfigure those automatically produced tags. So here's this dialog. You see here a couple of additional potential tags like emission trading systems. I could put as an additional tag, and maybe if I'm not sure if I would like to add international development, I can click here and could get a better insight into what's meant by this tag, international development. You see here are translations, is a short definition, is a kind of a visualization, how that's related to other things like to climate governance. I could click around here and get some context information around that, and I could decide to add that also as a tag maybe. And I could also look up in the knowledge graph some other tags which were not automatically found. You see the advantage of this autocomplete in this case is that it's really a consistent tagging system, since the knowledge graph contains all the synonyms, and you can assume there are no duplicates in this structure. For instance, with pool party thesaurus manager, such checks are done automatically in the background, and that's possible. I talked about that in the first part, because a knowledge graph is based on a standard, and there's some logics around that, and based on these logics and on those rules, you can execute some quality checks, and therefore this knowledge graph remains consistent over time. Of course, you could also introduce new concepts and new things into the knowledge graph. From that point, you could push it into the graph. and the graph manager, the taxonomist, could decide whether to introduce the proposed tag or not. Maybe it's just a synonym of an existing thing in my graph, or it could be rejected. Other mechanisms to extend the graph could be also corpus analysis. So there is kind of a way to extract potential candidates from statistical measurements, and that's also part of the pool party thesaurus manager, which could be shown in another video if interesting. So now I save the tags, and as a result, I now will have those additional tags I just put there attached to this document. So that's one example how to improve such a standard application like SharePoint. And now I go beyond this rather search-oriented application. I will show now an application based on a graph database. Just a few words on ways to integrate semantics into standard applications. So for instance, Pool Party has been integrated with, I would say, rather traditional search engines like Solar, Elasticsearch, and SharePoint Search. There are some other document-oriented search engines this kind of approach can be integrated with. So this already offers plenty of new options like faceted search, very precise similarity search, and things like that. But if you want to go beyond that and integrate data, as mentioned in the first part, from different types like structured with unstructured data, most frequently there's need for RDF and graph databases. That's one example or one advantage by using graphs instead of document-centric search engines, because you can virtually attach to anything, any fact. Yeah, it could be a value, it could be a label, it could be a picture, whatever you like. So that's one reason why graph databases make a lot of sense. And the second one is Sparkle or SparkQL, which has been used here in this little demo application. So for instance, all the document results are the result of a Sparkle query. The similar documents are a Sparkle query. Here all the faceted search is a Sparkle query. And it can traverse hierarchies of taxonomies. It can produce the results to visualize this as a chart, like this one is a Sparkle query actually in the background. So you see it's a very powerful query language over knowledge graphs. And the third advantage of a graph database, in contrast to Solar, Elasticsearch, and so on, is that it can be really used as a data warehouse. So you can integrate structured, unstructured data, XML documents, Excel sheets, whatever, and put it all together into one semantic ontology, and use rather the semantics of the data as an access point than just the simple search term we are used to when looking at Google and stuff. So with graph databases, we really go one step beyond search. It's more an analytics tool, and I will explain that a little bit on top of this application here. So what we see is the analysis of around 2,000 documents which were published in the field of pharmaceutical industry, and it's interesting to a research manager especially to see, okay, in which therapeutic areas has my company been most influential in the last couple of years, which of my subsidiaries or my countries, or which therapeutic areas we were most influential and stuff like that. And so here you see, for instance, over time how that changed, which areas have had the most impact, or I would like to know that per location and year, for instance. So that's also interesting as an analytics dashboard and not only as a search engine. Of course, you always get the corresponding documents, so those are the search facets in that case. And here are the documents. You can look up the similar documents and so on. Key to produce such an application is to have a knowledge graph in the background, once again, because um, it's based on several data sets. So there is some structured data involved, like the impact factors. There's unstructured data, of course, involved, like the actual research papers. And then there's also information around authors and sources and stuff. And actually, there were three different sources integrated, and as a kind of a glue on top, a knowledge graph was serving. This was partly derived from the already existing metadata. It was harmonized with help of an editor we've just seen, the Pool Party Thesaurus server. And then all the classified and annotated data was stored in an RDF graph database, in a triple store. And on top of that, the interface you see right here was produced. So of course, there's still typically simple search. So if you start typing, you will get, in that case, a categorized autocomplete. So now I can say I'm just interested in this journal, for instance. And again, I could say I'm just interested in a certain location and so on. So it's kind of a business analytics and business intelligence dashboard you see here in front of you. You might say, okay, we have been able to produce such applications for quite a while. I think another aspect you should be considered when using graph databases is to be more agile, and also the cost effectiveness of producing such applications. So it's in contrast to applications based around SQL databases. The NoSQL approach and the graph approach is a bit more agile. It can be developed over time, and then resulting knowledge graphs, of course, as frequently already stated before, can be reused all over the places. So it's an explicit model, explicit semantic knowledge model, and it's not restricted to just this application here. It could be reused in many different other applications and linked to other graphs and so on and so forth. So it's, again, really like a kind of a street network which could start to grow over time in your enterprise to help you to produce such applications like the one in front of you in a very agile way. So thanks again for your attention, and I hope you enjoyed this little tutorial. Bye bye.